I'm standing in the Costco checkout line with a 48 pack of paper towels, an oversized rotisserie chicken because nothing is small at Costco, an unnecessary amount of energy drinks because there was a sale, so I can't say no, and a kayak paddle. The kayak was a good deal. I'd be losing money if I didn't buy it. And I'm watching the receipt checker at the exit. That's the person with the yellow marker who looks at your cart before you leave. And something just clicks. I have been in system design meetings. I've drawn the boxes and the arrows on the whiteboard. I've sat through distributed system lectures with coffee in one hand and a diagram that, between you and me, I didn't fully understand. You know, there's a load balancer on the left, services in the middle, database on the right, all that fun stuff. Arrows are pointing everywhere. And here I am, standing in a suburb of Orlando, holding a kayak paddle that I have no use for, realizing that I've been walking through a distributed systems architecture tutorial for years. Welcome to Chaotic Commits. I'm Joanne Skiles, an engineer, holds a PhD, AWS community builder, professor, and right now, someone currently trying to figure out how I can sneak home a kayak on a Saturday without anyone asking questions. Anyways, Costco. Here's the thing about distributed systems education. The textbooks are correct. The boxes and arrows are accurate representations of real architectural concepts, but they're completely bloodless. Nobody has looked at a diagram of a rate limiter and understood viscerally what it feels like to be the one getting throttled. No one's ever read dead letter Q and immediately grasped the absurdity of that pattern. Costco makes it visceral. Every single concept in a distributed systems course, everyone, is visible on a Saturday afternoon in a Costco warehouse in a suburb near you. Authentication, ingress, rate limiting, observability, ingress validation, vendor abstraction, SLA commitments, dead letter queues, DNS, capacity planning, disaster recovery, breaking API changes, and microservice sprawl. All of it next to a 48 pack of paper towels and a kayak. I'm going to walk you through it. Now let's start at the beginning, the moment you arrive. You cannot get into a Costco without a membership card. That's the whole rule. It doesn't matter who you are. It doesn't matter if you've been coming for 15 years. It doesn't matter if you just need one thing and you'll be 5 minutes. It doesn't matter if your friend's already inside and you can see them. No card, no entry. That's authentication. That's your API key. Here's the detail that makes this a good analogy, not just a funny one, trust me. The card does not mean Costco trusts you. They're going to watch you the entire time you're in the building. They're going to check your receipt on the way out. The membership card is not a statement about your character. It's a statement that you're in the system, that someone can bill you, and that you agreed to the terms. An API key works exactly the same way. Presenting a valid API key doesn't mean you're authorized to do everything. It means you've been issued credentials and somebody knows who you are and there's a record. Authorization is a separate conversation. Authentication says, we know you. Authorization says, here's what you're allowed to do. The membership card is authentication. Once you're in, you go through the one-way entrance. There's a gate or a turnstile or a minimum clear lane. You enter from one direction. You do not enter through the exit. You do not cut through the loading dock. You come in from the front. That's your traffic ingress. Costco controls the flow, not you. They decide the architecture of how people move through this building. You're operating within that architecture. Your ingress layer works the same way. Requests come in through a defined path. They get routed from there. The system controls what happens next. The client does not get to call the database directly. That's not the entrance. There is an entrance. You use it. And right at the door, before you're fully inside, someone glances at your card. Not a long check, just a look. Just, you appear valid. Proceed. That is your gateway authentication. The lightweight check at the edge before you're deep into the system. Not a full authorization review, that's a different layer. Just the first gate. Are you in the system? Yes, proceed. Anything more complex than that gets handled further in. So you're in. Now you're inside the running system. The first thing you encounter, if it's a Saturday, which I understand we all make choices, the first thing you encounter is free sample stations. The sample person is the throttle. 1 sample per customer. Maybe 2 if you look enthusiastic and they're feeling generous. If you come back in 20 minutes, there might be a fresh batch and they might not recognize you. That's your retry window. Think about what rate limiting actually is. It is a service saying, I can only handle so many requests at a given time period. You can have one, come back later. The sample person is not being rude. They're not making a character judgment about your ability to handle a full portion of the mini quiche. They are protecting supply for the full population of people who are going to want this thing today. That's the entire purpose of rate limiting. You throttle the rate not because you hate the caller, but because you have a finite capacity and you have to serve everyone. A service that says yes to every request at any rate is a service that eventually says yes to nothing. The detail that makes this perfect, the sample person is not tracking you. There is no system. If you go around and approach from a different direction in 15 minutes, you might get another sample. That is how some rate limiting works. Session-based, not identity-based. Good enough, not perfect. The throttle accomplishes the goal without requiring surveillance. Now, the no windows. Because in case you didn't know this, Costco has no windows. There are no clocks on the wall. There's no natural white light. You walk in at noon, you walk out, it's dark outside, and you have been in there for 3 hours and you did not notice. There is no external reference point. You are inside the system, and the system has given you no information about time, context, or what the outside world looks like. That is what an unobservable system feels like from the inside. An observable system is when you can understand from the outside without breaking it open. You look at its outputs, its metrics, its logs, and you understand what's happening inside without having to go in and check. An unobservable system is this building. You're inside it, you cannot see out. Nobody outside can see in. Something can be going wrong in aisle 14 and nobody 3 aisles over knows until the announcement comes over to PA. If you've ever been in the system where you found out something was wrong because a user called, not because an alert fired, not because a monitor caught it, because a user called, that is a no windows design. You're in a building with no clock and no reference point, and you're surprised every time you walk out and it's dark. Now let's talk about the gas station. Every Costco has a gas station. The line is always 15 cars long. It's always 15 cars. You drive past it when you arrive, 15 cars. You come back an hour later, 15 cars. There was probably 15 cars yesterday. There will be 15 cars tomorrow. The gas is cheaper per gallon than anywhere nearby. Everyone knows this. The math always works out in the line's favor, so the line never goes away. That is your perpetually bottlenecked service. Every distributed system has one, the service that's always at capacity, not because it's broken, but because the value proposition is real and the demand is permanent and the capacity has not grown with the demand. The database that is always a little slow, the third-party API that every team routes through, the internal shared service that everyone depends on and nobody has gotten budget to scale. The line is not a bug. The line is a natural consequence of pricing and the demand being in a specific relationship to each other. You have been warned. You still wait. We all wait. Every system has this service. Your job is to know which service it is before you build something that depends on it at high volume. Now let's talk about leaving. The receipt checker at the exit. You've been in the store for an hour and a half. Someone scanned every item you put in the cart, you paid, you have a receipt in your hand, and right before you walk out, someone with a yellow marker, sometimes a pen, okay, looks at your receipt and looks at your cart. They're not checking if you paid, they watched you pay. What they're doing is checking what you're walking out with matches what went through the register. That's egress validation. That's output filtering. This is a check that distributed systems teams sometimes skip because they figure the input side handles it. The data came in validated, it went through the process, it must be fine on the way out. The receipt checker is there because it's not always fine. Sometimes extra dings end up in the cart. Sometimes the scanner missed something. Sometimes what came out of the process is not what was supposed to come out of the process. When you're building a system that returns data, egress validation is the question. Does what I'm sending back match what was agreed? Not did the code run without errors, not did the test pass. What actually came out, does it match the contract? Now, large pizza slices, the insanely large pizza slices. The Costco food cart is at the exit, not the entrance. You don't walk in past the pizza's at the end. You already paid. The transaction is complete. And right as you're walking out, the smell hits your kids' noses, and now grandma is buying pizza slices that are bigger than their heads. You did not choose this. You were already done. The main transaction committed and the downstream process triggered on its own. That is the side effect after the main transaction commits. And it's also why I don't do family trips to Costco. This happens in systems more than teams admit. The primary operation completes, all validation passes, the commit goes through, and then there is a downstream thing, a notification, a billing event, a caching validation, an audit log entry, and it was supposed to be logically separate from the main transaction, but it's not really separate. And if it fails, you now have a completed transaction with an incomplete downstream effect. The commit has happened. Grandma is already at the counter. What happens next is a different decision, and you better have thought about it. Let's go back. Kirkland Signature brand. There's Kirkland brand batteries, Kirkland olive oil, Kirkland vodka, which is actually pretty good, but I also mix my drinks, so take that with a grain of salt. Here's the thing about Kirkland. Kirkland is not made by Costco. Most Kirkland products are manufactured by the same factories that make the name brand versions. Same factory, same product, just a different label. You're not buying Duracell, you're buying the abstraction over Duracell. The Kirkland label is the interface, the implementation that somebody else's factory and then Costco negotiated access to it and put their own label on it. You get the batteries, you don't need to know who made them. That is vendor abstraction. Your application doesn't need to know which cloud storage provider is holding the file. Your service doesn't need to know which queue implementation is running underneath. You call the interface the Kirkland label, and it handles the implementation. If Costco switches battery manufacturers, you don't find out, you don't need to. Same batteries, same price, the implementation changed, the interface didn't. This is why you don't want your application code to be tightly coupled to a specific vendor's SDK if you can avoid it. The brand is the interface. The implementation can change. All right, we went through a lot. Now let's get into the commitments, the things that become load-bearing. This is the hot dog. Costco has sold a hot dog and a soda for $1.50 since 1985. $1.50 since 1985. When someone proposed raising the price, the co-founder, Jim Sinegal, said, and I might be paraphrasing slightly, "If you raise the hot dog price, I will kill you." He reportedly said that to his own president. That's how committed they are to this price point. That is SLA commitment made at an infrastructure level. I want you to understand what that means architecturally, because this is not about hot dogs. The price of the hot dog is not a business decision anymore. It stopped being a purely business decision sometime in the 90s. It is now a load bearing for the brand identity of the company. It is the thing that people say when they describe Costco. It is part of the value proposition that justifies the membership fee. You can't change it without paying a cost that exceeds the revenue it would generate. The hot dog became infrastructure. When you make a public commitment in a system, a public API contract, a guaranteed price tier, an integration point that customers have built on, every year that passes makes it harder to change. Not impossible, harder. The hot dog was a business decision once. Now it's an identity decision. Before you commit, understand what it will cost to stay committed. And understand that the cost of changing it goes up over time, not down. All right, let's move on. The returns counter. Costco is probably one of the most permissive returns policy of any major retailer. They'll take back almost anything. Some rules that do exist, like electronics within 90 days, but they'll take back food, a mattress you slept on for 4 years, a television after the Super Bowl. Some will return a Christmas tree in January. The policy is real, and Costco honors it, and the cost of that policy is baked into their margins. That's your dead letter queue plus retry logic. The dead letter queue holds messages that couldn't be processed. Events that failed, arrived in the wrong order, or didn't match what the system expected. They don't get discarded, they get held, and eventually, not immediately, not efficiently, but eventually, someone deals with them. The return counter works the same way, with one little caveat. In a real dead letter queue, the messages get routed. They're automatically when the process failures. Nobody has to walk back in with them. The returns counter requires you to initiate it. It's not a perfect analogy, but the behavior once the item is in the queue is right. The system holds. Some of it goes back on the shelf. Some gets returned to the vendor. Some gets written off. The important thing is the message is not lost. The item came back and the system handled it. The returns policy is a commitment to process the dead letter queue. Not in real time, but eventually. Now let's talk about our favorite part of Costco, right? The parking lot. The Costco parking lot has lanes. It has arrows. It has rules painted clearly on the ground. It was designed by someone who had a coherent theory about how traffic would flow through the space. And on Saturday morning, none of it applies. Someone's going the wrong way down the lane. Someone has abandoned a cart in the middle of the flow path. Someone is double parked waiting for a spot that opened 60 seconds ago. Someone drove diagonally across 4 lanes to get to a spot on the other side of the lot. The theory is clean. The practice is complete chaos. That's DNS. The domain name system has a hierarchy. There are rules. You ask for a name, you get an IP address, you go there. In theory, it is an orderly, well-organized routing system. In practice, caching issues, propagation delays, a record that was pointed at the wrong place 6 years ago and nobody changed it. A second server that is technically still authoritative but hasn't been touched since the contractor left in 2019. The theory is correct. The actual parking lot experience of DNS on a Saturday in production is a different thing. All right, last section. These are the things nobody pays attention to unless they need them. So, the tire center. Costco has a tire center. Did you guys know that? If you go to your local Costco, there is a tire center. It has staff, it has equipment, it is a fully functioning automotive service. I have been a member for years. Well, okay, that was a lie. My mother is a member and I piggyback onto hers when I'm coming in. I've never used the tire center. I assume it works. I have no recent evidence for this assumption. I've never seen it tested. I don't know how long it's been since anyone I know has used it. That is your disaster recovery runbook. Your disaster recovery runbook exists. Someone wrote it. It's in a Confluence page or a Notion doc or a Google doc that was shared in a Slack channel about 2 years ago and it hasn't been touched since. It has steps. The steps describe how to restore a service in the event of a major incident. It was written at a moment in time by someone who understood the system as it existed at that moment in time. When was the last time you ran through it? When was the last time anyone followed it from step 1 to the end in a simulated or real scenario? Not reviewed it, ran it. You assume it works. You have no recent evidence for this assumption. The tire center works, probably. The DR runbook works, maybe. Both answers are, I haven't checked lately. And both of those answers are fine until you need it at 2 a.m. on a weekend or you get a nail in your tire. The next thing, they move the thing. So this is a perfect example. I knew where paper towels were at my Costco, right? They're in the back right corner, past the cleaning supplies, before the food section. Years of muscle memory. I could navigate there without looking up. But one day they moved them. No announcement, no sign that said paper towels have moved, no forwarding address, just gone. And I wandered around for 15 minutes being furious in a way that I fully recognized was disproportionate, but I think you understand. That is a breaking API change with no migration path. My downstream process, finding paper towels, has been built around specific assumptions about where the resource lived. That assumption had been stable for years. And one day, the endpoint moved with no deprecation notice. No version bump, no transition period, no sign saying the old location will still work for the next 60 days. Everyone who built a workflow around that assumption is now wandering around the store confused. Semantic versioning exists for this reason. Deprecation periods exist for this reason. Consumer-driven contract testing exists for this reason. A sign in an aisle 4 saying paper towels are now in aisle 12 is a migration path. It's not a big ask. And finally, Costco started as a warehouse store. That's the whole business model. A big warehouse, bulk goods, low prices, that's it. Costco now has a pharmacy, an optometrist, a travel agency, insurance products, a gas station, a food court, a tire center that we've already discussed, a hearing aid center that my grandmother uses. You can buy a casket at Costco. I looked this up. It's an actual casket. They sell them, guys. That is microservices sprawl. You started with a service that did one thing well. Then there was a business case for doing one more thing, and then another case, and then someone pointed out that you already have a data to support a third thing, and the infra team said it would only take a sprint, and now you have a service that has an optometrist that will sell you a casket, and you're not entirely sure how you got here, but every individual decision made sense at the time. The right response to this is not always tear it down, rebuild it clean. Costco is extremely successful, but at some point you need a service map. You need to know what you actually have. Started as a warehouse, now has a full optical center and sells funeral supplies is not an architecture. It's a history. A history is not the same thing as a plan. Here's what I want you to take from this. Distributed systems concepts are not inventions of tech industry. They are descriptions of real coordination problems that arise anytime many people need to move through a shared space reliably. Traffic routing, rate limiting, egress validation, SLA commitments, observability, dead letter handling. These problems predate computers by decades. They showed up in warehouses and supermarkets and parking lots before anyone had a name for them. The textbooks put boxes and arrows around them. The boxes and arrows are correct, but they don't carry the weight of standing in a returns line behind someone trying to bring back a mattress they've had since 2019. They don't have the texture of wandering around a parking lot at noon trying to figure out who has the right of way. They don't capture what it feels like to walk into a building at noon and walk out when it's dark and wonder where the afternoon went. Architecture concepts aren't the insight. The people trying to get a giant rotisserie chicken on a Saturday afternoon are. Next time you sit down to design a system or review an architecture diagram or argue about whether you really need dead letter queues, think about the returns counter. Think about the sample person protecting the supply. Think about the tire center you've never tested. The concepts aren't abstract. They're just dressed differently. And if you got something out of this one, send it to an engineer friend. Send it to a non-engineer friend who has been unreasonably angry in a Costco parking lot. They now understand something about DNS. You're welcome. This is Chaotic Commits. I'm Joanne Skiles. See you next episode.